Andrew, at Plotlogic, you're applying AI to increase the efficiency of the mining industry. Talk about the state of the industry today and what are the main challenges we face there.
Yes, there's three quite significant challenges that the industry is facing right now. The first one is, of course, the transition to a clean economy. And as many people would know, the mining industry is run predominantly on fossil fuels. So, about depending on how you include the assessment, it's somewhere between 3 and 10% of global emissions comes from the mining industry. So, the mining industry itself needs to decarbonise. Secondly, and coupled to the decarbonisation of the mine sites themselves, mines also need to produce more metals that have ever been produced in the history of humanity in order to make the transition to a clean economy a reality. So we need more lithium, more cobalt, more nickel, more copper than has ever been produced. So it's an unprecedented requirement for new demand for new metals to transition to a clean economy. And then thirdly, there's a requirement for these mines that are producing all these metals, not just to be free of carbon and producing metals that transition the economy, but also have very negligible environmental impact on the local environments on which they're operating. So the ESG play for mining operations is quite rightly massively important as the industry matures and grows. We can't, of course, produce all these metals that we need for a clean economy if we destroy the planet along the way. So they're the three big challenges that the industry is facing right now. And we see this as a really important time for the industry to get a lot of things right and help create the industry and provide the metals that the world needs.
Do you think these challenges are somehow connected with the fact that a lot of the mining industry is not, so to speak, at the front view of the population, but rather hidden in some difficult to reach locations or even some geographies far away from the places where the minerals are consumed?
I certainly think that's a part of it. And what we're seeing now is that as we transition to a clean economy and people rightly ask all the way back in the supply chain of where the inputs are coming from. For example, if you're driving an electric vehicle, you want to know where all the components come from and that they're being ethically sourced. I think that in combination with more ease of accessibility in terms of satellite remote sensing data and the like has meant that essentially a mine could have been out of sight, out of mind for a very long period of time. And now, it's very obvious what's going on and where those mines are physically located and the sort of impact that they're having. So I think those sorts of things are causing a change there. Historically, 100% agree that it's difficult to access those mining environments. I've come from a mining industry background myself and worked in extremely remote locations and traveled to very remote locations. So certainly not the sort of places that many people would put on their tourist map. So it's it is a little bit historically of out of sight, out of mind.
By the way, taking a short detour here, where did you go when you work in the mining industry? What were some of the craziest places you had to visit or work at?
I've worked in everything from desert environments in Australia to travelling up into the foothills of the Andes in South America. Spent some time travelling to mine sites in Africa in sort of quite remote places and on some rather interesting domestic flights to get to and from different mine sites. So yeah, there's certainly no shortage of remote locations that mines are located in. Matter of fact, one of our new clients right now is an Indonesian nickel producer that's helping power the transition to a clean economy, and the technician that we send out to support that implementation had to take 2 internal flights and then literally got a small power boat to to go up a river for about 6 hours to access the mine site. And then when they got to the mine site, they had no communication, so they had to literally install a tower so that we could have internet data connected back to Jakarta. So it was pretty interesting experience for those techs to be working in. And again, it's a really important thing for us to be able to help these operations modernize, become really efficient as to how they produce the nickel and not destroy the environment, while at the same time making sure that we produce the metals we need for a clean economy.
This is a very vivid picture of a way we currently produce minerals on this planet. Your technician sure will have a lot of experiences to tell their kids about, or their grandkids. The other issue you talk about in your materials with the mining industry is that industry productivity kind of flatlined and even maybe declined, unlike most of other industries where productivity has grown up significantly since the data is since 2000, and it's data from the US Bureau of Labor Statistics. So I wonder, what's the reason for the stagnation or decline of the productivity in the mining industry?
There's quite a few factors at play. One of them is that the industry is very capital intensive. So, it costs a lot of money to establish a new mine. Traditionally, the approach that's been taken by the industry to produce more is to get bigger equipment. Bigger equipment costs more money. Create bigger mills. Bigger mills cost more money. What that means is, the capital intensivity is really high, but it also means that the flexibility is very low. So you get a limited amount of capacity to increase or decrease production based on supply and demand requirements. That sort of manifests through to the way that the commodity markets have traditionally played out, where it is very much a supply and demand cyclical environment. If the price for a particular commodity is high, it's kind of this mantra of almost production at any cost, because you'll make money while the price is high. To an environment where it's a low price environment, everybody is just cutting costs as much as they possibly can. So, breaking that cycle is, I think, the big challenge that needs to be taken in order to drive underlying massive productivity increases. And the report you refer to shows, from the United States, it shows that essentially labour force productivity has flatlined and gone backwards in the mining industry, which is really a function over the last 20 years of those different factors at play, where there hasn't been the ability to have that longer term whole of industry view of how do we actually make this industry super efficient and super sustainable.
When you have an environment where demand for your product changes radically from year to year, it's very hard to plan ahead. And in financial markets, you would think that speculators, the professional speculators, the ones that should buy low, wait till the demand is back, and then sell high, should step in and arbitrage that issue. But it looks like there is no set of players in the market right now that would be able to absorb such huge amounts of the production to compensate for the decline in demand, just to return them back in the market when the demand is back.
Exactly. The commodity markets are absolutely massive. So we can't really sort of think of a company or a person that could have that sort of leverage. I think also I probably oversimplify the cyclical nature of the industry. As I think while there's been historical trends and mega trends as to what's happened in the industry, the interplay and what changes on a monthly or annual basis, is not perfectly trackable in terms of increased supply or increase in demand. So for a commodity speculator, it's certainly a very, very challenging and high risk environment to try to make the market in that context.
And the only actor I can think about that could have stepped in and try to bring stability there would be nation state or even a union of nation states that would treat it like a strategic petroleum reserve in the US, try to pump in the commodity when it's cheap and then release it back when it's expensive.
Yes, certainly. I think nation states have some capacity to do that. We've seen in the past, countries do that where they've increased. Traditionally in gold, we've seen that play out where countries have increased their gold reserves as the gold price has gone down, as they've seen it strategically important. Other times they've offloaded some reserves. I think there potentially is a trend for that in other critical metals into the future where nation states see the imperative to make sure that they've got that supply always under control and maintain some stocks there. So that might be an interesting motivation for people to do things a little bit differently in the future.
So, do you think there is an opportunity for such a dynamic, such a actor or set of actors to emerge in the future?
I think absolutely in the critical metal space, all these metals that are transitioning to a clean economy. I think there's much more scope than what we've had happen in the past in terms of structural changes to make sure that those supply chains are resolved and consistent. And I think if we can take the volatility out of those markets, that will actually have a positive effect for the mining operations to become more efficient, more sustainable, because they can actually start thinking longer term about what is the actual roadmap for innovation in the space, with confidence that their pricing environment will hold up and sustain them to actually affect those transitions while they go through those changes.
Yeah, because in essence, we do know the demand will be there 5 years from now, 10 years from now, 20 years from now. There will be cycles. The economy works in cycles, but those cycles will reverse themselves in a due time. So you don't need to be a genius to predict that the demand will be high, I think. So it does make perfect sense to have something like that, a huge hedging facility. But let's talk about Plotlogic and what you bring to the table. In a sense, you're increasing efficiency of the existing mines and fighting that productivity decline, or hopefully reversing it back.
So essentially, the way that mining operations work, for those not super familiar with the space, and I'll oversimplify it at the risk of creating some sort of egregious error. But essentially, what you do is you go to a mine resource. So exploration has happened. You've identified this high deposit of gold or copper or whatever it is that you're chasing, and you'll do a whole bunch of exploration drilling in order to delineate that down to a level where you can raise money to go and start the mine. And so these exploration drill holes, they might be literally, 50, 100 meters apart, even more, and they'll drill these very, very tiny holes into the ground, and then use that to then create essentially a model as to what the ore body looks like. So the ore body is the commodity in the ground and the rocks surrounding that commodity. When mining occurs and you've raised $500 million to many billions of dollars to start the mining operation, then what happens is the mine operator comes in, they build a mill, build all the plant, and then they bring in all the equipment. And essentially the cycle of a mining operation is relatively straightforward. They'll drill holes in the ground that are relatively closely spaced together, so maybe 10 meters apart, depending on the operation. And they put explosives in the ground, blow the rocks up, dig the rocks out with machines, excavators, trucks, etc. Take that to the mill, crush it up, and then extract the commodity from it. And then they repeat that cycle over and over again. And whether it's an open cut mine or an underground mine, essentially it's a similar sort of process. Obviously, in an underground mine, there's a different type of method than the traditional sort of open cut method, but the idea is the same. You blow up the rocks, you move them from one place to another and the like. So the big problem with that, and the reason why, one of the main reasons why the industry lacks significant efficiency in this space, is that when you actually build this mine, you base it on a whole bunch of exploration data. Then when you go to operate the mine, the amount of additional information that you get is quite low. So you have very low information density about the ore body. And so these things are geological phenomena. They move, they have different properties, literally from meter to meter. Yet what happens is the mine operators will make an approximation about what the mineral content is from literally one rock to the next by making some sort of assumption. And that matters, because when you then go to make the most efficient decision about how you extract the resource, in what order you do the sequencing, how you actually run your mill, what sort of processes you use to optimize the extraction, you're just basing that on a whole bunch of quite coarse assumptions. And so at the core of what we do is we go into the mine and we scan all the rocks and we say, okay, we can use our AI and sensors to actually tell you with a very high degree of accuracy every single rock before you've even touched it or mined it, and then provide more information as that runs through that mining sequence that I described, to then tell you exactly what the best way is of treating those particular rock mass or group of rocks through the mill. So essentially that's what we do. It allows the mine to be super efficient, in terms of being able to really think about what is the right order to extract the rocks. When you're actually extracting those rocks, what's the best way to treat each of those, in terms of, do you put it through the mill? Do you actually, you thought it might have been under your exploration model a high grade section of ore, but it was actually all waste material. So you're just going to burn energy to and slow your mine down without without actually giving any more commodities. So by having all this information, you then make really sophisticated decisions literally every minute of every day to drive a significant increase in productivity for those resources.
Without the technology that you provide, how did they get this information, or how do they get this information right now?
Yeah, so right now, most mines will essentially, they'll literally scoop up buckets of rocks. So they'll drill a hole in the ground. There's a few different techniques for doing that, and those holes are literally tens of meters apart, etc. And then from that hole, they'll take literally a bucket of rocks, so a small bucket, maybe 10 liters, etc. And they use that bucket of rocks to represent that entire rock mass. They take that bucket of rocks, they put it in a truck, they drive it to a laboratory somewhere. The laboratory runs a whole bunch of chemical assay, wet assay techniques to then determine what's in those rocks, and then they assign that very small mass back to a larger representative area. So again, it's a sampling methodology where they actually take a very sparse sample of rocks and then assign that to a larger body of knowledge. So it's around about 0.05% of all the rocks on a mine are actually sampled in a traditional method. And what we do is we with our new technique, as we evolve up and have all these sensors across all the different parts of the mine, we end up sampling around about 26-27%. So literally 1 in every 4 rocks, and we can do it obviously non-invasively and in real time. So it gives you this unprecedented accurate knowledge of the actual rock mass that you're extracting.
So in your case, it's much richer information, much more granular, and also the turnaround times are much shorter. You don't need to drive to the lab. You can get it right on site.
Absolutely. So we scan with our sensors, we run our AI. Not every mine is connected to very high speed internet connection. So we run a whole bunch of edge algorithms. We will build our AI in the cloud, and then we deploy it on the edge so we can run these algorithms essentially in real time wherever the device is located, and provide that information to the mining client.
And in terms of the productivity gain or efficiency gain, how do you measure the results of implementing your technology, what kind of metrics, and what kind of impact you've seen?
Yeah, so there's a few parts to that. I think at the largest level, we deliver unprecedented improvements in productivity for those mining operations. So we're still building the technology and the instrumentation that actually measures those uplifts. The measurement of uplift is, as you'd imagine, in a complex system, non-trivial because there's multiple inputs and multiple outputs. But essentially, we target a 20% uplift in mining performance, which is quite substantial for those mining operations. And the way that we do that is by reducing the amount of waste material that goes through the mill, and also making sure that the blend of the actual ore material that goes into the mill is the perfect blend to be able to give the best performance. So they're kind of a couple of the big levers. There's also a reduction in the unit costs that we get from literally having to haul less material than you would otherwise do, making sure that you're not double handling material, all those sorts of things. So they're kind of like at the macro level. We then also get benefits really at the sort of unit level, where essentially we take a traditional process that's quite expensive and quite time consuming. We automate that so it's less people physically in the field, which helps drive higher degrees of remote operation and automation, which results in less labour on site, less fuel consumption, etc. And also on the turnaround time of how we actually give these results means that the engineers and geologists can do their job more efficiently. So there's multiple areas where we can actually measure tangible uplifts in performance.
I read about one of the mines that, thanks to your technology, was able to extend the production time frame. I think talk about some of the case studies, some of the benefits for the mines from using the technology.
Yeah, so one of the mines that we work at the moment, they have a method where they're taking those very small buckets prior to us coming along and spending literally millions of dollars every month, sending them to a laboratory to get this assay process done. It's quite slow, so it takes for them to actually get enough assay results back to be able to make a determination of the right sequence to extract next. It takes them about 7 days to 10 days to actually collect all that information back. And that's important because the machines, these massive earth-moving machines, if they don't have a plan, if they don't actually have the right plan back from the engineers and geologists of where to dig next, they literally stop operation. So they literally park up waiting for a dig plan of where to dig next. So by getting that information back essentially in real time, as quickly as we can scan those samples, we can give them a result. It does two things. One, it gives the opportunity for the geologists to run more scenarios to optimize their extraction sequencing. And two, it means that they've always got a plan so that the machine knows exactly where it can be digging next, so it doesn't actually park up. So we actually reduce the delays for that mining operation quite significantly. And of course, those delays have a direct cost and productivity impact because there's people operating equipment standing around waiting for a plan. Machines very expensive to have sit idle, so it just allows the business to keep moving material and doing it in a very efficient way. So that's one example of a client that we've been working with recently. In another example, we've been working with another client where they have a lot of challenges even getting their geologists to get into the mine operation because of being able to actually get the geologists to physically locate to, as we spoke about up front, one of these really remote locations and all the transport, logistics, accessibility associated with having those people on site. One of the key jobs that they have to do is they have to go and what they call a face pickup, where they literally go to the mining faces that are being extracted by excavators, and then they'll make an assessment based on whether or not it's aligned with the geological plan or whether there's some sort of further local variation that's coming in. So what we've been able to do is automate that process so much so that the geologists can do their job from literally any city anywhere in the world. I could give you a link to an access point now where you could go in there, and as the results are coming off the device, you can see these beautiful maps of the mine faces essentially coming up in real time that are not only providing this information that you can do some base level assessment on, but then unprecedented level of automation and sophistication around determining exactly the right way to extract that face, or if there's any alarms or triggers or the like. We run our AI in order to provide that guidance for the geologist to then be able to look at that mining face and go, yeah, we're happy with that, or we've identified a flag here that needs something different to be done. So that's a significant uplift in that mining operations ability to do what was a traditionally laborious, time-consuming process, important, but not happening often because they physically couldn't get people there, to now being able to integrate that into their daily workflows, and they're expanding that out across their portfolio of assets as we speak.
And in that first example, the lab, you said they paid them millions of dollars every month to process those samples. Did you replace all of that work, or it's still now kind of use both avenues, you and the lab?
So we essentially replace that work. One thing that we do from our AI models, it's really important for us to have commercial grade, very reliable, very repeatable, and very auditable AI results that people can have confidence are actually working all the time. So one of the things that we do is we take a small percentage of those samples. It's around about 10% of samples that would normally be done through a traditional assay approach. We do our own laboratory assessment on that as part of our audits, checks and balances, and we use that for two things. One, to provide the client with assurance that there's a second independent method checking of some of these results so that they maintain their reliability and usability. And then the second part is it also allows us to, in certain circumstances, increase our labelled training data, which then, of course, enhances our models even further. So we do send a small proportion of the samples off to the laboratory, but theoretically that's a function of the essentially the audits and governance processes that we've built to give our system that commercial grade reliability.
Right, this calibration process must be present because ores change, our body changes, and you need to make sure that your systems you trained your data on are still reliably identifying the new types of the rock that you send them.
Absolutely. So we work on the basis of building generalizable models that can work essentially straight out of the box on any mine site they go to. We started in iron ore, and we've done additional models into the copper space and manganese, and we're just building out our nickel model as we speak. But essentially, we have this idea of building a generalizable model that works straight away. So it doesn't matter which mine site you go to anywhere in the world, we can actually give you results immediately. We then do some localization where we might sort of say, okay, we're seeing some localized variation here. We might tune the model in order to meet that. So having the additional training data come in is valuable for that local site, but also it feeds back into our generalizable model as well. So as we bring in more sites, the models become more and more robust, and we're seeing that play out, literally in every commodity that we go into, which is pretty exciting. We had this theory, going back a few years ago, that we'd get a really good network effect from having multiple mine sites that are providing additional label data and making these models more robust and more reliable as we scale up. And that's essentially what we're seeing play out now. So as more clients come online, everybody gets the benefit of the new label data, which is, of course, desensitized, so that it's not, you can't attribute it to a particular mine site, but it just gives a better quality model for clients to work with.
Right, it makes perfect sense. And in terms of the customer profile and the minerals you currently addressing and your roadmap, you talked about some others that you're adding new metals there. So what is the profile of the customer, and who are maybe not a good fit for Plotlogic?
Interestingly, we sort of think about the market in segments. So traditionally in the mining industry, what they do is they produce these industry cost curves where they say they put every mine site on the planet into quartiles, and they say you're a first quartile, second quartile, third quartile, or fourth quartile producer. And essentially, way to sort of think about it in a sort of classic supply and demand environment is first and second quartile producers are making money on a long run average price, and then third and fourth quartile producers are not. Everyone's trying to either turn off or sell their fourth quartile operation, and the third quartile operation they're trying to make a bit more efficient so they can push them down to the second quartile, etc. So that's the sort of, I guess the sort of, again, quite basic but macro view of how people think about the mining industry. Interestingly for us, we actually supply great value to those third and fourth quartile producers because, for them, being able to drive a significant efficiency gain can literally mean the difference between surviving and not. So for us, those producers are actually a really important cohort, and we've seen that already where we've had marginal producers come and talk to us saying, like, this is an existential threat for us if we can't find ways of being smarter about how we extract this resource that we're missing out. So that's an interesting client profile for us, and it sort of complements the first quartile producers who are also a really great cohort for us because those producers are all about the incremental amount of value that they can deliver to their shareholders. Often that's it's a high quality resource, so it's really important for them that that strategic asset is being extracted as efficiently as possible. So they're also really interested in our tech. So essentially, we work in all parts of the spectrum, from really large producers all the way down to juniors, from high margin producers where we can make their mines more efficient, to really low margin producers where it's all about how do we actually get that extra ton out and make the mine profitable and sustainable. And of course, all of those operations, whether they're a first quartile, third quartile producer, still have this requirement to be super efficient and sustainable from an ESG point of view. So that and finding ways of being more efficient to decarbonise the mine site. So we feel that that interestingly the tech works really well in all those environments. Our models initially were built in iron ore. That was historical. Some of our early research was done in that space, and we were able to build from that to get some things happening quite quickly, a degree of sophistication. So we were quite involved in that space. We're doing quite a lot of work now in nickel, in lithium. Copper is really important for us. So we've been building those models out over time and getting them to a point of high commercial utility. So we haven't identified a commodity that we don't think is suitable for us in terms of our ability to add some value there. One of the reasons why this tech stack that we've built is so important is because it is quite ubiquitous. It can work across any commodity type that you could imagine and be deployed in any mining method that you could imagine. So we built that tech stack from the ground up with that in mind.
Let's talk about it. The tech stack. The system is a set of sensors and AI to process the data from the sensors. Talk about what are the parts of the system, and what kind of technologies you use on the AI side of things.
Yeah, so essentially there's a few key components to our tech stack. The first is the hardware. And so we identified really early on that there was this missing information, that didn't matter how good your general AI was, there's this information that didn't exist. And you'd know from your experience with AI that you can't invent stuff that just doesn't exist. So you've got to actually have some information to work from to begin with. So we identified that this sparsity of information, this literally lack of information to be able to make very accurate predictions on a rock by rock basis, didn't exist. So we built this hardware that was all purpose built around how do we get as much information about the rock properties as we possibly can, as fast as we possibly can. and then made a decision around what sensors to include based on that, that underlying requirement, if you like. And so in the hardware, we've got a bunch of sensors, as you pointed out. We use a combination of LiDAR to provide spatial information and some other textual information about rock properties. We've got also the couple of the key sensors that we use for particularly some of the more advanced AI stuff are hyperspectral imaging sensors. So we're collecting information from 400 nanometers out to 2500 nanometers at a very high resolution. To put that in context, a typical color camera essentially has 3 channels that works between 450, 750 nanometers. We have 410 channels that work between 400 and 2500 nanometers. So we have this massive amount of additional information in the infrared non-visible part of the spectrum that we then use in combination with LiDAR. We also have some position sensors and the like that we bring all that together, fuse all that data, and that's the sort of data capture point. The second piece then is how we actually ingest that data. There's a huge amount of data. So a typical sensor might collect 100 gigabytes worth of data per day. And we've actually got to find ways of being able to collect all that and then do something useful with it, make sure that, again, from a commercial point of view, we're showing portability, traceability of the data all the way back to its origin. And so we have essentially a data ingestion model. Then we have our AI layer, which is once we've actually collected all that data, we've QC'd it so that we're happy with the accuracy and reliability of the underlying input data. Then we run a whole bunch of AI over that, which then gives the predictions around the rock mass properties. And then the last layer is really where the client comes in, where we have essentially an interface, platform interface. It's a web interface, which then has a whole bunch of apps depending on the particular point of interest for a client around whether that's, as we spoke about before, that sort of face mapping application or doing generalized scheduling where we can actually provide these results and then provide the user with this sort of app space, if you like, to be able to then use that information literally every minute of every day. So they're sort of the main chunks of how we think about our tech stack.
Usually when the new product arrives, it means it wasn't possible before. It's either the need wasn't there or some parts of the solution were not available. And in your case, it looks like the need has been around for quite a while. So it's about the parts. And I wonder which parts were missing and what was the most important things that happened recently that allowed you to build what you've built at Plotlogic. Is it on the side of the sensors or is it on the side of the algorithms?
Yeah, so 100% correct. This problem has been permeating through the industry time immemorial, and understanding that material property is critical to the entire industry. So it's not a new problem. It's something that people have just accepted in the past because they couldn't find a different way to do it. The two things that are probably the most transitional or transformational in terms of how this technology can now be applied. The first one is actually not so much in the sensors themselves, but actually finding a way to run these sensors in really, really harsh environments, 24 hours a day, 7 days a week, in very remote locations. So all the parts that go with that in terms of data connectivity, data storage, onboard data processing at high speeds, doing that in environments which some of our environments are currently operating over 50 degrees Celsius, can be very high humidity, very, very muddy, dusty, all those sorts of things. So actually building the capability that allows that data collection to happen, essentially real time in very harsh environments, and be able to, store that data in a way and process that data in a way that's useful and be able to access it remotely, I think is probably the first piece of it. The second piece is really on the AI. So again, like even 5 years ago, this type of AI just wasn't possible. It was at that point in time it was very theoretical. It was able to be sort of done in a laboratory environment and done in the very controlled circumstances. But having these generalizable AI models that could be just deployed and run and give very sophisticated, accurate results and do it in a way that is quite seamless, I think is the other really transformational piece of work that need to happen. To do, to really build that, we had to make a massive leap of faith, 4 years ago, where we had the lab work and the theory that sort of said that this would work, but what we didn't have was massive amounts of labeled data from all over the world, all these different mines, etc. And to collect those labeled data sets is massively expensive and very time consuming. So we took the gamble, if you like, to say that, well, if we collect all this data, this really high quality labeled data, and we get it from all these different locations, and then we think we'll be able to move the dial on this AI, and essentially that's what we've been able to do.
Quantify the hardness of collecting the data and talk about how did you go about getting the data for initial training.
It's interestingly, and it sort of goes all the way back up front to when you mentioned about the location of mining operations. So collecting data, labeled data, getting into and out of mine sites is actually a non-trivial challenge. So for a lot of mine sites, they require very special access permits. You need to have a whole bunch of additional safety inductions, etc., just to get there. They, as much as they're really large operations, they do try to staff them with as fewer people as possible because of all the transport and logistics of running flights, charter flights, or driving people in and out of these remote locations and then housing them, etc. So getting onto a mine site is actually notoriously difficult. And so being able to collect those labeled data sets requires a couple of things. One, it requires the time investment, so it's really time consuming to get to these locations, and two, the money investment to actually back yourself to go ahead and collect this data. But then on top of that, there's also this massive relationship element, which is actually being able to work in with mining companies and mine sites and say, hey, we're doing something important here. We know what we're doing. We're not completely green to the industry and have no idea what's going on. We'll be able to come onto your mine site. We'll be able to work safely. We'll be able to work in with your business and not cause lots of problems, etc. So, all those elements really need to come together in order to get those things. I think it's been an advantage for us. We've got a team. My background prior to starting this company was actually in the mining industry, and we've got a team that actually has a huge amount of mining expertise. So we understand the nuance of how to work in and around mining operations as much as we understand the AI and all those other elements as well. So I think that sort of uniquely places us to be able to be able to collect this information, which other people would probably find difficult to do.
It's definitely a very rare combination of industries. You don't hear mining and AI in one phrase too often.
No.
You said your focus on iron ore was historical, stemming from some theoretical work in the lab. Talk about why you started with that metal, and then how do you think about what to choose for the next one or two types of metals to work with?
Prior to us starting the company, there'd actually been several attempts at building this type of technology for the mining industry. And most of that had occurred in iron ore. So two sort of quite large mining companies, BHP and Rio Tinto, had both had their own internal programs where they were looking at building this technology. And so they'd done some base level research around using this type of tech to do the sorts of things that we're doing with varying degrees of success. Fast forward to when we started the company, we made some really good progress quite quickly. And then we were approached by BHP who said, hey, we're excited with the progress you're making. We'd rather just partner with you than continue on with our own program. So we've been working closely with BHP for several years now. So we're able to sort of, I guess, leverage off some of the foundation work that they'd already done and been a great commercial partner. Rio Tinto had also developed their own, in-house research program, and their lead researcher actually came in 2019, I think it was, and actually asked if he could join our company because he saw the progress we were making compared to, Rio seemed to be stalling out on their program, and a whole bunch of questions as to why they'd probably developed that technology in-house versus opening it up for the world to be able to make the industry more efficient. But ultimately, so the lead researcher from there came to work for us. So again, he'd published a whole bunch of research papers in this space, and came with a sort of wealth of knowledge around that foundational public research that had happened that allowed us to continue down the path of doing work in iron ore. So iron ore has been a great foundation experience for us, and also it's a really large market. So in terms of the mining industry, it is actually a really significant part of the mining industry. So from a straight commercialization perspective, you want to be able to develop into a large and developing market, which iron ore certainly ticks those boxes. For us, we also see copper gold is really important. So we do a lot of work in copper now, and copper is also a really important metal for transitioning into the clean economy. There's literally not enough copper that's been produced in humanity to last, essentially the next decade out if all of it was recycled. So there's this massive shortage of copper that's required to transition a clean economy. So we like copper, and again, it's also a large market. We actually think, and the stuff that we've been working on now, the two next commodities we've been doing a lot of work in is nickel and lithium. And so lithium, as I'm sure you're aware, is a huge play in terms of transitioning into the clean economy and battery metals and the like. Nickel is also in that same category. And so we see the nickel play is really interesting. Our tech works really, really well in nickel. We've got a couple of live deployments already. Our models are already working off the bat in that space. So for us, nickel and lithium are probably the two next areas where we'll focus most of our attention. We kind of have this, like classic Pareto 80-20 type of rule where we'll focus most of our energy and attention in some certain areas, but not at the expense of working in other domains. We also have done work in manganese, which is also an interesting critical metal, and we also work in tungsten. So so we can actually work in those other commodities as well, and we build up those models, on a case by case basis as well. So we're certainly not restricted to iron ore, copper, nickel, and lithium, but certainly that's probably where we're focusing 80% of our current cohort of clients at this point in time.
And the rest of the 20% is more of exploratory, and you plan to bring them eventually to the 80% bucket and make a mainstream, or you envision that there will be always like one-off ad hoc projects?
No, I think it will bring them more mainstream. So, one of the things we did last year as we grew the company from just me and a truck and a bunch of sensors to an actual serious business is we put on a CFO last year. And so our CFO is very much like, make sure that you do, 80% of your work in area which we know is already commercially done, and then keep the 20% as a sort of experimental developmental work, which then ultimately becomes the 80% bucket as those algorithms and tech pieces evolve in their maturity.
Yeah, this is a good framework to think about things, to avoid that issue of having to pick whether you do it big or not do it at all. You always have this experimentation bucket. Speaking about you personally, you started in mining, then you switched to returned, I should say, back to academia to get your PhD. What became the trigger for you to get back to the studying?
Yeah, so I started in the industry in 1998. Did a mining engineering degree, then did a master's degree in finance, and basically went into operations management. So I was running a whole bunch of mining operations for a relatively large public listed mining company. But I've always had this huge passion for being able to provide the world with the resources that they need, but do it in a way that doesn't screw the planet up along the way. So something I've always been really uh, challenging myself and my team with when I've been working in the industry, and sort of got to a point where it was, I think, 2016, and my partner, I've been talking to her about a whole bunch of stuff, probably recognised that to affect this massive change as to how I could see things really evolving differently and taking the industry to unprecedented levels of sophistication, recognise that being able to do that inside a mining company with a career path I was going down was probably very, very unlikely. And the company I was working for was very supportive, great company to work for, but it was obvious that that was not something that they were considering on their horizon anytime soon. Also recognised that I had quite a technical deficit, sort of had these grand ideas, but kind of no real way of doing it. So made the call to go back and enroll in a PhD, to really just focus in on this particular big idea, but also help build some more stronger technical foundations that could then be used to inform the business and how we're growing. So so quit my job, had um, two young children at the time, and went back to being a student for a few years while I worked on this opportunity. And then ultimately, there was always a view that I wanted to be able to work on this stuff to then have an impact on industry. And so we got to a point after a couple of years of doing a PhD that was like, yep, there's a serious business idea here. And that's ultimately how I went off and formed Plotlogic, to then start taking that combination of research and industry experience and convert that into a business proposition.
What was the most unexpected thing of going through PhD? What was something that you don't expect getting into this?
So I hadn't done any computer programming since I was, doing university the first time round, and apparently Fortran was no longer a thing. So I was I was blown away by my complete lack of knowledge of all things computer programming, and B, how much the sophistication of things like being able to run Python, essentially quite intuitively, and C++, which is where we built most of our stuff. Just how much it evolved after literally taking, I guess 15 years is an extraordinarily long time for anybody familiar with software and AI space. But for me, just taking this snapshot of software engineering and computer programming from one point in time to then literally 15 years later, and seeing how much it had moved and how much more sophistication had come into the industry. That was probably the biggest thing, and it was a massively steep learning curve for me. So I had to spend a lot of time, reading and writing a whole bunch of really buggy software and going again. And so, I'm glad now that I actually have a team of software engineers who routinely remind me to not write any more lines of code. But I'm proud of the fact that at least the foundational piece of work I was actually able to cobble together myself.
This is remarkable. Not every CEO of a company can brag about putting lines of code into the core of the system. And in terms of growing your team now, hiring more people, how do you think about the culture? What kind of people you bring in?
Yeah, so you touch on culture. Culture is a really crucial part of our business. Everything that we do from recruitment and retention of people really fits around our cultural model. At our foundation, we've got essentially three key values that are super important to us. One is we work on this idea of principles over paradigms. So for us, that's about whoever you are, no matter what background you come from or what experience you have, you might have a whole bunch of paradigms, a whole bunch of mental models about what works or doesn't work. But really, we always challenge people to go back and get to the root cause of a particular scenario or situation that we're in. What's the underlying principle at play here? And then making sure that when we get to the core of the principle, then we can come up with solutions beyond that. And think it's a really important part of how we work as a business, that we're always challenging each other on that. The second one is really about, we call it an MVP mindset, but it's not so much a minimal viable product, but a maximal viable product within a particular time frame. So we time box decisions and say, what's the best we can do within a particular time frame? We have to keep the business moving and keep the business growing. So let's create a time-based decision and do the best we possibly can within that time-based decision. And then the third part is this idea of what we call ego at the gate, where putting those first two things together means that you're not always going to be right. You're not always going to be the smartest person in the room, and some of the stuff that you're going to produce within a time frame is just not going to be pretty. So having this idea of leaving your ego at the gate. It's important to have ego. Everyone's got one. From a competitive point of view, people want to win, etc. But within our team, it's important that we put our egos aside and be willing to be open about how we do things. And so I think these are the three sort of pillars of our values. And it's sort of not the cliched, communication, collaboration. We take all those humanistic values as a given. So we expect that people do, communicate openly, collaborate, are inclusive about how they treat each other, respectful, etc. So all those things are, we take as a given, and we assume that people, being decent human beings, will do that. And certainly, that's an important part of how we hold each other into account as well. So that we start with that idea, and then when we're recruiting people, we're really looking initially at the character of the individual, more so than competence or any other sort of element. We're really looking at the character and sort of saying, is this the type of person that we feel could work in this environment? And then within that, we then look at their chemistry and competence as well, in terms of like, are they going to be a fit for the business? And the fit for the business is actually a really interesting one, because there's always a risk that if you have a bunch of white middle-aged males, then the easiest person that's a fit for your business is another white middle-aged male. So when we think about a fit, we're thinking about not so much, we want people that look like us and talk like us and think like us or have the same background as us. We want people from a fit in terms of how do we actually build this really inclusive environment. That means that you're going to, come from all walks of life and be able to work in with a business. So we need people that are essentially inclusive when we think about being a fit. And that brings people from a whole bunch of backgrounds, which is hugely beneficial to our business.
Out of those three pillars of your culture, when you interview people, what do you say, what is the rarest to come by?
I don't think I've ever met anybody that doesn't have an ego, even the people that say they don't have an ego or whatever. We always joke about at work that the ego's at the gate, but sometimes people leave the gate open. And so I don't think I've ever met anybody that doesn't have an ego, and I don't think I probably would want to meet anybody that doesn't have an ego, because I think that's a really instrumental part of us as humans, having that sense of self and sense of ego and the like. I think so while I've never come across anybody that 100% can leave the ego at the gate the whole time, I think that from an interview point of view, I think people that are super able to sort of genuinely think consciously about all those different facets in terms of what that actually means in a workplace, and having that sort of self-awareness about is this my ego talking, or is there something else at play? I think is really, really rare, and we do come across people like that from time to time that really have that really strong intuitive self-awareness. I'm not one of them, so I need regular coaching from my team. So I'm sort of pot kettle black in that particular regard, but it's a work in progress.
What I noticed is that attaching your ego, if you cannot get rid of it, attaching it to the success of the group changes the things dramatically, because it starts, instead of arguing about whether you're right or not, you start thinking about whether the group will succeed or not, and your ego is now pointed into a little bit different direction. But it's absolutely it's definitely very hard.
That's in all seriousness, we sort of have this sort of the kitsch ego at the gate thing, but that's why we say leave the ego at the gate, because what we're trying to encourage our team members to do is to think of like inside our work environment, inside our business. We leave the ego outside of that, but obviously outside of that, we want to be successful. We think we're on a really important mission to add significant value to the industry, but also really change the way that resources are extracted, and the value that that can add for broader society is really important. So, we want to be proud of that. So when we go back out the front gate, we pick our egos up and we get excited about our team successes.
Let's turn to the future now. The need for raising efficiency in mining is obvious to everyone. It's obvious to miners themselves. They talk about it. So, two questions here. What's your vision for Plotlogic? And what do you think are the next inflection points that should happen in the industry for it to fully adopt the solutions that you bring to the market?
Yeah, so our vision, for the future is that, we feel that to deliver full automation there's a few things that we know will really drive a massive uplift in performance of the industry. And that's really centered around digitization, taking an industry, making sure that digitization is completely fully integrated into the industry. And there'll be people in the industry that say, "Oh, we do a huge amount of digital transformation already," but I think there's piecemealing certain digital pieces of your business and then taking a more holistic approach to how that entire business or industry runs. And I think they're two different things. So there's always examples of, oh, we've here's an example where we've done something digital in the mining industry. So that's not really what I'm talking about when I'm talking about digitization. I'm talking about a holistic approach to how the entire operation runs. So I think that is really central to the future of the industry. And I think that really unlocks things like full automation, full remote control, complete control over that ore body down to literally rock by rock level, and then the whole of mine optimization that comes with that, and the reduction in environmental legacy that comes with that, and the uplift in productivity, the uplift in new metals that actually drives the economy as part of that. So we see ourselves right at the center of that. I think we've got a really important role to play in being able to provide really the engine of that business, which is the ore body itself, providing that knowledge, doing it in a way that's really seamless as how that data is collected, aggregated, and fed into other systems. And then that whole of mine optimization is a really critical part of where we see ourselves playing in the future, to be able to say, okay, now you have this unprecedented information, we've given you solutions that can help each stage of your existing process. How do we pull all that together with our mining clients to make sure that entire business is working, with a very, very high degree of sophistication? So I think, to me, that's where we see ourselves placed in the future. It's a very, long-term view. We're getting huge progress and huge in-rounds already, but that's certainly the direction that we want to continue to go. I think in terms of inflection points, my sense on it is it's more of a slow burn than a straight inflection point. I think that we're getting to a critical mass now of ESG requirements where the industry is really becoming, and should be quite rightly, more and more responsive to investor requirements, stakeholder requirements, Indigenous group requirements, traditional owners, etc., about actually how we make the most out of these scarce resources and do it in the most efficient, sustainable way. So I think that's just growing and growing to a point where that we have to be able to do things differently. And I also feel like there's the critical mass in terms of transition of critical minerals. And I think that that's another piece that really needs to be addressed to unlock more, as people realise that you can't just go and explore and continue to explore and find a deposit, but then wait 10 or 15 years before you can start it, and all the things that come with that. So I think getting more out of those existing elements is something that the industry is, if they haven't already in some regards, some people have, some people haven't, woken up to the fact that actually you've got to be able to do more from those existing operations. And I think the third inflection point, if you call it an inflection point, but again, it's probably more of a slow burn, is really around this whole, how do you decarbonize an existing mining operation? So there's been some good progress made in terms of hydrogen-powered trucks and the like. But we've seen in historically, the first autonomous haul trucks were introduced into the industry, more than 20 years ago now, and the adoption rate of those new autonomous haul trucks is like less than 2% of the global haul trucks that are operating on mine sites. So if we don't do things very differently, then I think there's a risk that will be exactly the same case with carbon-free sources of energy for running existing mine sites. And there's been lots of claims, grandiose claims made by some industry participants have talked about they're going to have their fleet completely carbon free by a certain date or time without actually having any understanding of the technology that underpins that, or how that actually physically transitioned, or the capital costs associated with it, etc. So I think a lot of that will get called out over the next few years, and then it'll be really important for mines to actually to step up and do those things.
Decarbonization is hard for mines with all the heavy equipment. The electric vehicles are just definitely weren't ready to replace the combustion engine there. And alternative fuels, clean fuels, may be the solution for sure. I'm watching it closely. In terms of the energy transition, you mentioned the huge demand placed on the materials, minerals, metals by that transition. And also the miners themselves, they openly discuss the fact that new mines that are being opened, first of all, it takes a long time to get them online. And second, they are smaller and of lower grade. How concerned are you about this dynamic? How big of an issue we should expect there with the even availability of some of those materials?
Yeah, so the declining grade is certainly talking about productivity, industry productivity before. It's also one of the key factors that's decreasing the productivity. If you look at the unit output, if there's less ore coming out, because the grade is lower, then of course your productivity on a net basis is going to go down. And I think smaller scale operations as well, tend to be you don't get the same economies of scale that you get from a large scale mining operation. And of course, the third factor then is more physical mines. It's more physical footprints. It's more physical environmental legacies. So for me, I think that those the new mines that are coming online, it does concern me that these new mines are coming online. We're not really addressing the fundamental supply shortages. The commodities exist. It's just going to be more and more difficult to get them out of the ground, consume more energy, consume more land, and cause more environmental damage. So I think, again, this is one of the reasons why I'm so passionate about this business that we've created and in the process of building, is that it actually allows you to get more out of those existing operations. And by building this technology in a way that then gets embedded into the way that businesses run in the future, it also means that in 10 years' time, when a new mine comes online, they'll actually implement this type of technology from day zero. So they're actually being very responsible at how they extract that resource, as opposed to just digging another hole in the ground and creating another environmental legacy. So, so I kind of feel that we've got this really important role to play in helping the existing cohort of mines become more efficient, and particularly in those areas that we've been working, but also looking to the future and saying, as these new mines come online, we actually want them to come online using very, very sophisticated and sustainable practices. And some of our clients are actually late stage development projects that have actually got that in mind. They're working with us now so that when their mines come online, they're already using the best possible technology to be really sophisticated about how they do it. So we're seeing that as a trend within the industry, where we're having these late stage projects come and approach us and say, yeah, we want to use this. We don't want to wait till we've been operating the mine for 5 or 6 years before we come and implement this technology. We actually want to do it from day zero. So it's a pretty exciting when we see that type of behaviour occurring in the industry, where again, 5 or 10 years ago, we wouldn't have seen that at all. So it's great to see that a lot of the industry participants are really really stepping up and take the challenge that we see as being important as equally as they also see it very seriously as well.
It seems like it's been a race for us, starting from a very easy to get deposits, tapping them first, and on one hand, we're getting into the deposits that are harder and harder to extract. On the other hand, we have to come up with the technologies that increase the efficiency of these processes. And it's exciting to see you on the forefront of this race, never ending race, I'm afraid, until we get to fully circular economy. But until then, we definitely need more of these innovations like the ones Plotlogic produces. Where can listeners learn more about the company? Where can they follow you on social media? And if you're hiring, also talk about it.
Yeah, so we're most active on LinkedIn. It's probably our main social media channel. We're about to launch a new website, so our website's currently a little bit outdated, and we're in the process of relaunching that. We've put a lot of engineering effort into building cool technology, not cool websites. So our website's a little bit behind the times, but we'll relaunch that in the next few months, which will be another good source for people to be able to keep it up to date on news and information. So that's just plotlogic.com. In terms of roles that we're recruiting, we essentially are always recruiting with various degrees of acceleration. Right now, as always, we're always looking for amazing engineers. If there's great engineers that are, again, really mission driven and excited by what we're doing, always keen to have a conversation and make opportunities available. Also, product management is a key area for us that we're really focusing on, getting really top tier product managers, product designers within our team, because it's really important for us that that people often think about the mining industry as being always a whole bunch of equipment and you kind of just do stuff, but ultimately we still have clients to serve, and we have to make sure that the people that are using the technology are delighted by the technology and it can actually add a significant amount of value. So it's really important for us to get some excellent product managers into the mix as well. So they're probably the two big priority areas that we're recruiting for at the moment. We're also always expanding our sales team, so we're in a position where we're growing really quickly and continuing to grow. So we've got a lot more opportunities than in our pipeline that we can currently manage. So always excited to talk to people who have got some good experience in dealing with B2B, large enterprise value type contracts as well.
We'll add those links to the show notes. Andrew, thanks a lot for joining me today. It was great talking to you.
Thank you. It was a pleasure.